Hello, everyone. Thank you. Thank you for coming. Many thanks to the organizers. I'm really glad to see multiple communities join forces to gather you all in this room. I'm very glad to see you all, and congratulations on an in-person event, finally. I'm Andrey Breslav, and today I'm speaking about Shoulders of Giants, the languages that Kotlin learned from during its initial period of design. An important disclaimer I need to make. I used to be involved with Kotlin quite a bit for 10 years, actually. I was the lead designer on the project. I wrote a substantial portion of the slow compiler you're all suffering from. So it was the previous chapter in my life. It ended about a year and a half ago. So I'm now not officially representing Kotlin in any way. Everything I say is a lie. You can't take JetBrains on it. So it's all my personal memories, opinions, so on and so forth. I'm not speaking for the team here. Although I love the team, I'm friends with them. We talk sometimes, but it's not coming from them. So, the main reason why I'm giving this talk, and I actually started giving this talk a few years ago, is this. This is how people behave. They fight a lot. They fight a lot on the internet, and specifically about technology, and specifically about programming languages they like and don't like. And there is one pattern in these discussions that I have a problem with. And it goes like this. Here's the language I like. And that language you like stole all the ideas from the language I like. So you have no right to like that other language. And I think that this needs a bit of a reality check. I have empathy for these people. They love a language and want to defend it somehow. But this particular rhetoric isn't really constructive. So what I mean here is actually learning from another technology is a good thing. So a very bad thing to say about a programming language or any other engineering effort is they took no ideas from anybody. It amounts to they're completely crazy. They want you to relearn everything all the humanity ever knew, and you are gonna be stuck with that technology they invented from the ground up. Very rarely, completely reinventing everything is a good idea. So normally how we work is we look at other people's work, we analyze it, we know the inside of it, we understand how it works, we put it together, we rehash it a lot. So we take some ideas, we throw out other ideas, we mix and match them in different ways, and we get something hopefully better. We ship it out to you, you try it. If you like it, we incrementally build on top of that. If not, we backtrack and do something else. So building on top of other people's work is good. You should do it. If you like my idea, please use it and build on top of it. One thing that makes it emotionally nicer is if you give credit, people will be happier. So I'm here to give credit to those other people whose ideas I used proudly. So one important thing to know about Kotlin and its design is that, first of all, it all started back in 2010, so it's been quite a while. And we had in mind this vision of a pragmatic language for industry, and every word in this phrase matters. So pragmatic means no fluff and no research, academic, whatever craziness. So we didn't mean to invent anything. We happened to actually invent something along the way, but it was never a goal. And we deliberately wanted not to advance the frontier of the scientific understanding of computer languages we wanted to make an engineering product for engineers. And the industry part of this phrase is also important because we wanted something for large projects, large teams, long periods of time. So it's all, for scale and so on and so forth. So when we thought about it, of course, there was a goal of benefiting JetBrains and many other goals for making users productive and so on and so forth. But my personal sort of ambition that I didn't share too much, but I couldn't help but having, was to sort of advance the common sense on computer languages. So not the academic frontier, but the mainstream frontier. And you're the judges of whether we did it or not. And other language designers hopefully will come on stage and tell you whether they used our ideas to advance their languages or not. But I'll be talking about how we built that on top of other people's work. And by the way, I'm very, very grateful to everybody who released anything before Kotlin. Because, you can feel like there was a race, for example, between Java Lambdas and Kotlin being released. But actually, if someone releases before you, they get to walk the minefield. Their users will be the first to give them all the feedback. Not only will love it, but also it sucks this and this way. And we, those who didn't release it so early, get to hear the feedback and change our solutions to the same problem. So when somebody does it, like Brian Gatz of Java is really eager to have pattern matching in Java. And I, throughout my whole career, had many reservations about pattern matching. And it seems like Java may actually have pattern matching in the end, and let them have it first. We'll see how people use it, and if that works for them, maybe Kotlin gets it. So we'll let them walk the minefield before us. And this is how it works. So we walked the minefield before other people on some fronts. They walked it for us. Some other fronts, there is a circulation of ideas. So during this talk, I'll be taking your questions as I go. I'll be calling for questions during sort of logical breaks. If you have any questions right now, put up your hand and I'll give you the stand. No questions? Okay, go ahead. Okay, the question is, there is a problem of copyright and licensing, and for Java it's a big deal, isn't it? So the good thing is ideas are not actually copyrightable, and even the Java, the language, is explicitly public domain, for example. So the language itself doesn't belong to anybody, which is nice of its creators. The library is copyrighted, and the huge lawsuit between Java and Google, between Oracle and Google, is about that. But the language itself is public domain. And I think it's a good thing, and no language should be patented or copyrighted because it will stall the progress. So fortunately, in this regard, we're in the clear. Okay, I understand that questions can be hard to hear. I'll be repeating them, so don't hesitate and put up your hands. First question from me. So what languages did Kotlin learn from? What do you think? C#, Java, Swift, Scala, Groovy, JavaScript. Oh, that's an insult. Anything else? Okay, so I need to give, so this is not a full list, but most of you were right. Of course, we learned from those languages. These are the versions that were actual during the active development time of Kotlin. So like things that came after we couldn't really learn from. There is a big It was a huge disappointment for me that Swift was unveiled so late in its development. Kotlin and Swift started apparently roughly at the same time, but we didn't have a chance to look at Swift while we were developing Kotlin. So most of the things that are similar between Kotlin and Swift are coincidental. Unfortunately, I would love to learn from Swift while we were working on Kotlin, but we didn't have a chance to. So it was unveiled in 2014, and we were already shaping up the 1.0 by that time. Didn't change much during that period. But otherwise, yeah, we learned from many others. I'll give you examples during this time. So when I say Scala, for example, it means Scala 2, not Scala 3. Probably the team is now learning from Scala 3, for example, but during that time wasn't there. Okay, wait. One important question. What do you think? Which language influenced Kotlin the most? What's the biggest influence? C#? Any other options? Java, yeah, that's right. Java, of course. Kotlin was designed initially as a successor to Java. It was designed for the JVM. It was influenced very heavily by our own experience with Java, by the virtual machine we were designing for, so on and so forth. So Java is by far the biggest influence, but many others did their share too. So what did we take from Java? Many things. So only like the basic shape of the Kotlin's runtime and the basic notions, concepts in the language all come from Java. We have classes and interfaces. We have a single inheritance for classes, multiple inheritance for interfaces. Interfaces don't have state. There are constructors. There are no destructors. There are nested in inner classes, annotations, method overloading, so on and so forth. And we inherited many difficulties from Java as well, like autoboxing, for example, in the JVM is inevitable. And we inherited interesting things like runtime safety guarantees that we basically took for free from the JVM. Okay, and there is a question about autoboxing and Valhalla. When we say now with Valhalla, it's not really now. When Valhalla finally lands, and I wish the team all the best with that because it's a huge effort. Kotlin will need to adapt. Fortunately, Kotlin will need to migrate the same way as Java. Like all the Java code bases will be incorporating new things with Valhalla, and Kotlin code bases will as well, with the only benefit of us having a compiler that can do some things for you. So we'll be doing the same thing with the rest of the world, but maybe a little nicer because we can sweep some things under the carpet for you. When I say we, I mean the Kotlin team, I'm not on the team. So all these things we took from Java. We liked some of them. We couldn't live without some others despite not liking them. But some other things we left out. And many people say that language design and engineering in general is largely about not what you take, but what you don't take, what you leave out. So we left out quite a few things. On the language level, we don't have a monitor in every object. We don't have finalizers. Our arrays are different. We added nullability, so no implicit nulls everywhere. Collections are different. Statics are different. We mostly got rid of raw types, which was quite an endeavor. And we have a unified type system. There are no primitives as such. Everything is a class, so on and so forth. So we inherited a lot from Java. We sort of removed many flaws from the language surface. And this means that we had to somehow mitigate this because all this exists on the runtime level. So here's the first code example. And what language does this resemble the most? C#, correct. Yeah, to me, it also looks like C#. So we have, why? Yeah, because we have a column for supertypes. We have a unified supertype list. No extends and implements separately like in Java. We have interfaces and classes in any order, so on and so forth. It all comes from C#. But of course, other things are coming from Java. Like we have the notion of inner classes. C# doesn't have them. We flipped the bit here. Like Java has inner by default. If you have a class inside a class, it's an inner class, and you implicitly capture a reference to an outer instance. The keyword here is implicitly, and we tried to fight as much implicitness in Kotlin as we could. So it was an explicit design goal, no pun intended, explicit design goal to make things explicit in Kotlin. So basically, if you don't do something all the time, 100% of the time, you need to make it explicit. And this is why we moved the default to be nested, no memory implications. By default, inner, explicit memory capturing with a keyword. So this way you know that your program is doing something in addition to just declaring class. So this is how we inherited things and changed them on the go. Questions here? Should be pretty basic. Go ahead.
Is that why there's so much similarity with Swift? That one concept?
Is that why there is so much similarity with Swift? Well, hard to tell. I'm not really sure if Swift had this explicit design goal, but it makes sense. So, and they are very sensible people. So I'm not surprised if they had the same reason. Another example, many characters here. And here it's kind of a blend of Scala and C#. So we have many things here. First, a primary constructor, right? So this class has a constructor. It's declared right in the class first line. And this is something that we didn't invent. Scala invented it. We embraced it happily. And since then, everybody else embraced it. So yeah, thanks, Martin Edersky, for this invention. And cheers to everybody for finally picking it up after so many years. So yeah, and you can have properties right there in the constructor declaration. You have a supertype, a superclass constructor call with all the parameters. All this comes from Scala, and it's excellent. The rest of it, we have properties. Properties, the overall syntax is sort of C#-like, but not quite. I'll show you the differences in a second. Internal, the keyword comes from C#. The concept is very appealing. It's something internal to a module. Modules are not a thing still. Like they sort of exist on the JVM. They didn't at all when we designed it. So it's a language thing in Kotlin, not a runtime thing. We have to sort of emulate it on top of what we have. It's leaky abstractions, but we still like it because it's very useful in terms of modeling how you want to structure your code. Explicit override keyword comes from Scala. Good idea. Actually, C# people have it as well. So all this is sort of a blend of the two. Any questions about this? Okay, so now I want to talk about the fun keyword. Who knows what language fun comes from? Erlang. Interesting. I don't actually remember what they say for functions in Erlang. It may be, but it's not the origin in this case. Okay, it's okay to not know, but if there are any other guesses. Having fun. Okay, yeah, I'll talk about that. Actually, it was a difficult discussion. Because, the point was initially that we want all the declarations to be aligned in the code. Like we have val and var, 3 letters each. We wanted 3 letters for functions. And if you speak Russian, Russians are sort of fond of 3-letter words. Yeah, there are some people speaking Russian. Okay. So yeah, but the 3-letter word for function is a proper noun and an adjective in English. And we were like on the fence whether it's okay that in our language you'll have private fun, for example. Is it okay for a coder to have private fun or public fun? Or later we added actual fun and public actual fun. Or you can now expect private fun. No, not private, but expect public fun. So, we were kind of on the fence, and we needed someone to walk the minefield before us, and preferably someone whose native language is English. So we looked back on the programming language history, and there is a giant of functional languages, Robin Milner, who designed the ML family of functional languages, and he had fun for functions. So that was our sort of blessing from a giant, that it's okay to have fun as a programmer. So other people, of course, do it differently. There is anything from function, which is long, and those languages tend to do other bad things. And on the other end of the spectrum, there is FN, which makes guns, and I'm not sure it's a good thing. Or func, which is 4-letter words, which is bad in English, So yeah, we stuck with fun, and we're happy for it because people are making those puns and having some fun with it. Any questions about fun? Go ahead. Oh, yeah, it's a very good question. So the question is, Python and Scala, by the way, have def instead of fun. It's actually a bit puzzling for me why academic people use word def for their function declarations, because def stands for definition, and it's not always a definition. So there is a difference in programming languages theory. There is a difference between definition and declaration. So you can declare something, and it's basically a header. Like you say, I will have this method. And then there's a definition, like in C++, you have a body with your full class prefix and everything, and that's a definition. So in many cases, for abstract methods, for example, in Scala and Python, these are not really definitions, there's a declaration. So there is a contradiction there. And also, it's, on the class level, it's a little weird that you have definitions inside a class, but not all the members are definitions. Like some of them are properties, like vals and vars, and definitions on top of that. Makes little sense to me. So we stayed away from that. Apparently, nobody cares. Like any 3 letters you use, apart from those 3 Russian letters, probably work. So yeah, this worked as well. More questions? Why not 4? Yeah, we wanted it to be aligned. When you have declarations like val this, var this, fun this, we wanted all the keywords to be the same length. Yeah. So this is not Kotlin. What language is this? I hear something like Python. Python doesn't have curly braces. No. Closure. Closure only has round braces. Any more guesses? Scala. Yeah, this is Scala. And this is an example of how we got the idea of properties from the Scala side, but didn't take any of the syntax. Because Scala has properties, very rich mechanism, but with this scary squigglies like name underscore equals, which stands for set name in Scala. I was kind of scared by this. Didn't want this in the language, so we didn't go the Scala way. But on the other end of the spectrum, there is this language. What is it? CSharp. Yeah, this is CSharp. And the problem here is very many curly braces. And I'm curly myself, but I can't stand this much. So, we didn't take this literally, but we took most of it, and then I hacked on the parser until it understood this. If you know basic grammars and parsing and so on and so forth, you can see a challenge here, but it's doable. It works in Kotlin. And here we actually use something which is not really mainstream, used to be not very mainstream at the time. because words get and set are not real keywords in Kotlin. When we say keyword, traditionally, it means that anywhere where the parser sees this word, it knows it's special, so you can't name a variable get. But of course, you can have a function called get in Java, right? So we can say get is a hard keyword in Kotlin. Lots of Java code will not be callable. So this is a contextual keyword, a soft keyword, where the parser knows where it's reading the input, and only in the context of a property get means something special. Otherwise, it's just a name. And Kotlin has lots and lots of soft keywords, which helped us a lot, so we can do interesting magic with it. And I see other languages using more and more of that. CSharp now has a lot of soft keywords, and other languages are sort of incorporating this too. We are not pioneers. People use soft keywords before us, but we use it like extensively, and I made sure that every keyword that what doesn't 100% have to be a hard keyword in Kotlin is not. So we have lots of those soft keywords in the language. Any questions about properties? How many hard keywords do we have? I never counted really, but a few dozen, I think. Yeah. Basically, the criterion for this is whether it has to distinguish between an expression and a declaration. Like class is a hard keyword because it can happen in a place where you don't know whether it's the start of a new expression or just the middle of something. Yeah. So speaking of leaving things out, Kotlin has classes, and classes are ordinary in Kotlin. And Kotlin has interfaces, and nowadays interfaces in Kotlin are straightforward. Java has them the same way, but we started before Java had them. So it's actually, at the beginning of Kotlin, we didn't have interfaces, we had something called traits. And we looked at Scala, and Scala had traits. And if you look at every other, like really every other research language in the world, they have something called traits, but they do not at all agree on what traits actually are. Like everybody means something different or slightly different by trait. So in the Scala case, what they wanted, which is very natural, was some implementation inheritance, so multiple inheritance of implementation. In Java vanilla, before Java 8, you have to inherit all your implementations only from superclasses, and no code and no state comes from any interfaces. This is very limiting. People suffer from it. The biggest issue is when you add a new method to an existing interface, all the hierarchy below it has to implement this method. So there is no gradually adding methods to your existing interfaces, and the Java standard library suffer from that. That's why they added this. So what's called default methods in Java. We thought that single implementation inheritance is very limiting, and the initial ambition with Kotlin was to actually solve multiple inheritance in a general case. Like we looked at C++, it's scary, ugly, and weird there. And we were like, okay, we'll do it well. Like, we'll fix everything that C++ couldn't. Well, that fell apart in a pretty ugly way because you don't solve multiple inheritance of state. If you want your class to inherit from multiple classes, each of which has state, you have to figure out how to manage constructors of those classes, because every piece of state has an associated constructor, and you have to call this constructor from your inherited instance. And those constructors are general functions, they can have effects. So it matters a lot in what order you're calling those constructors. So all our hacks of like, let's try to get rid of that didn't work at all. Like it was completely broken from the beginning. So the middle ground would be to do what Scala did. So Scala's traits are interfaces with method bodies and state. So you can declare fields in Scala's traits, but you can't have constructors, which means basically that all your initialization code goes into the class body, which means you have a constructor actually in a trait, but it has no parameters. So to call this constructor, it's trivial, you just call it. And the only question is in what order are those constructors called? So there is a complicated algorithm that figures out a deterministic way of calling all the superconstructors from all your traits. I looked at this algorithm. I imagined myself explaining it to normal people, and I said no. Like no state inheritance at all. We'll do without it. We'll just have implementation inheritance for methods and no state, no constructors in interfaces. So that's how we basically converged with the Java folks on the same idea. And when Java 8 came out, we used their implementation underneath, and now Kotlin has interfaces the same way as Java. And that was a dead end in our design exploration. Yeah, so that's that weird algorithm for calling constructors called the linearization rule. But there was a residue from this whole thing with multiple implementation inheritance, multiple state inheritance, because the only implementation possible for this on the JVM is, of course, by delegation. When you extend multiple classes, you just instantiate them and keep the instances and delegate to them. So we dropped all that, but delegation is a useful pattern. So we had a shorthand syntax for that, and you can now delegate to an interface with a simple keyword by. This is like the heritage of this attempt of taking on the multiple inheritance thing. Delegation to an interface is an interesting feature. Many people like it. Who likes it, by the way? Not many people. Oh no, people it's falling out of favor. All right. Yeah, the thing is, I don't like it because it's a huge headache from a language design standpoint. We had, I don't know how many hours we're trying to work around this in the future. Like we edited to Kotlin 1.0, so we couldn't drop it. And like all the next versions, we had to work around lots and lots of limitations of this because it plays badly with everything. Like it affects inheritance and everything under it. So it's a huge pain. I think I had a hope to do something about it while I was in Kotlin. Probably the Kotlin team will do something about it without me. Yeah, so in any case, this is just creating a delegate field underneath and delegates all the methods to it. And this is not something you see in other languages. Also, on this slide, there are many other things you don't see in other languages, like the init keyword for the anonymous constructor. We didn't want to duplicate the class name because it's a useless repetition, so we added a keyword there. If we learned more from Scala in this context, we would do it the Scala way, where you can write expressions in the class body, but this makes syntax very cumbersome and the parser goes crazy, so we didn't do that to make the IDE a little nicer. We have, of course, default parameters, and the implementation of that was a great contribution by one guy who hated the way they were done in Scala. So it's like an improvement on what they had done. They were considering at some point doing something similar, so maybe it was actually retrofitted back into an implementation that Scala had later on. Any questions about this?
Yeah, Python also is some kind of delegated properties.
Yeah, so the comment is that Python has something like delegated properties. That's correct. Kotlin has two different features with similar names. One is delegation to an interface with the word by, and another is delegated properties with the word by. Delegated properties are fine. There's nothing wrong with them. I love them. They are very useful. Delegation to an interface is problematic, and I regret adding it to the language. So yeah, that one, Python has something similar, and we did this sort of a statically typed version of that. So something interesting on this slide. There is a keyword that's notoriously lacking. in this syntax. Can you guess what it is? New, correct. This slide, if rewritten in Java or Scala for that matter, would have two new keywords, right? So one is to signify constructor, another is to start the creation of an anonymous class, an anonymous instance of an anonymous class. So it was another interesting discussion that we had during the early time of Kotlin. We looked at the grammar and figured that the new keyword wasn't necessary. So we could have it just for the sake of it, but there was no technical necessity. So we were like, okay, this looks like a pretty big thing. Like in Java or CSharp or C++ or wherever, you have every new instance creation clearly visible in the code. You have a keyword in front of it, and you know what you're doing. You're creating an instance. Will it be very bad if we take that away? It's noise on the other hand, right? So you have this keyword that's not necessary. Probably you're filtering it out with your eyes anyway. So we, again, needed some blessing from a giant. And that giant was Guido van Rossum, of course. With Python, he had no new keyword. We talked to some people who knew Python well and did a lot of coding in Python. And they said it was okay. You didn't really care for those object creations. Of course, Python is not that that sensitive to allocating resources, but still. So we took the liberty of leaving new out. We got an interesting effect. You can now, in Kotlin, you can overload a constructor with a function. Right? You can have a class foo with constructor, and next to it you have function foo with a capital F, and that will be overloading. So you can do sort of secondary constructors outside of the class, which is kind of nice. People use it. It's sort of an extension constructors. But the flip side of that is that you can't use the new keyword for an anonymous class. So we had to do something else. When you do an anonymous class, it's actually an object, so we use the object keyword. And just reuse the rest of the syntax for it. Any questions about this? Go ahead.
There's a long trend in Java to bring some stack-based versus heap-based objects. There are some things that they want to create. Let's assume that you want to create an object, and then if you want to create it on the stack,
oh, okay.
And then a new is mandatory because you want to create it on the stack.
Yeah, so if we had an option to create an object on the stack or off the stack, that would be a whole new world. So if Valhalla existed when we designed Kotlin, or if we designed Kotlin for another runtime, we'd have a lot more options of all sorts. But we were very constrained, like everybody is constrained actually now, with the existing JVM. So no allocations on the stack. You're stuck with your primitives. And actually, we did play a little bit with trying to allocate things on the stack if they have only primitive fields and so on and so forth. But this falls apart miserably, like you can't do it. So yeah, we'll wait for Valhalla, and maybe we'll add something back into the language to signify this difference, but I'm not sure how this will play out. Any more questions? Go ahead. Antelar, yeah? Oh, no. No. Yeah, okay. Antler is a parser generator. It's a very interesting project by a very cool guy, Terence Parr. And many people use it for ad hoc parsing. The thing is, almost no production language ever uses any parser generator at all. Almost no one. Very few languages use parser generators that their own teams wrote for those languages specifically. The thing is, generated parsers aren't really good for production compilers. They are very good for things you do ad hoc, like very quickly, and so on and so forth. But if you want really full control over your performance and all the aspects of parsing, it's easy enough to write recursive descent yourself. It's not a major part of your compiler work anyway, so you don't want a generator. if you have a different algorithm for parsing, you have different problems. Like if you have table-based parsing, it's a nightmare to report errors. So everybody I know just have recursive descent handwritten. Nobody does any generator at all. Yeah. So another thing from Scala, singletons. And this is an important story, actually. When you're trying to do an object-oriented language from scratch, you're trying to do it right. And there is one thing that's very weird about practical mainstream object-oriented languages. They're not really fully object-oriented because there is all this static stuff going on, right? So who has a string util class in their code base? Now, if you don't have, probably your project is not in Java, or it's a very new project. Yeah, so the thing is, it's kind of wrong that you have to create a class just to have a utility function. So everybody looking at a from scratch object-oriented language is trying to get rid of this static thing because it's wrong, right? So, and their Scala tried, and their solution was, let's have top-level functions that are static by nature, and you don't have a class around them, they're just functions. And if you want to encapsulate a bit of static things, you just put them inside an object, inside a singleton. Makes sense? So we liked that, and dropped the static keyword altogether, took objects from Scala as they were, and implemented Kotlin. Just, it's absolutely the same as in Scala. But then there is a one step forward. Since you want to say things like data.create, so call a method on a class, which is static by nature because class is a global entity, you need to have something like a companion object. And there, Scala's approach was very ad hoc. Like, if in the same file with class foo, you have an object on the top level named foo, they have a privileged relationship. One can see the privates of the other, and it's a companion object, and then you can say foo.something, and it will go to the object, and if you create an instance, it goes to the class. This looks kind of, ad hoc and not very nice, because we break encapsulation, although it's in the same file, it's still weird, so we didn't like that. We went with this syntax that I regret. So we did the same thing, but we put the companion object inside the class. So it has an obvious privilege to see the privates because it's inside, and it doesn't have a name, or the name is optional. So you don't have to duplicate the name. Who hates this? Oh, not so many people. Nice. So many people don't care. Yeah, so it's awkward. You create another level of indentation. I'm not happy with that. And also, the way we did it is a nightmare in terms of inheritance rules. So this, I know for a fact, this is on the list for reforms in the future versions of Kotlin, because this is a headache to design. Questions? Yeah, go ahead.
Why did you call it a companion?
Companion, yeah, so this term we just took from Scala. They called their objects companions, and it was the same. Yep.
It feels like with the high-level methods, it's like when you have it, you don't need the
Okay, so the comment is, if you have file-level functions, you don't need companion objects. Not quite, because companions have a private access to class members. They can look inside the class, and it's important because encapsulation otherwise wouldn't work. So we have to admit that for practical reasons, we need statics. And the 10 years of Kotlin design made me believe that. Okay.
Isn't this like a workaround so you can use static methods in Java?
It's not quite a workaround because in pure Kotlin, you want that kind of code anyway. But for Java, we have special tweaks if we want to expose something as a Java static. So you have those annotations just to bridge with the JVM. But even if there were no Java at all, we would have this, because you want to say data.create or whatever. More questions?
What will replace component objects then?
Well, I can't speak for the Kotlin team, but I would try to resurrect statics in some way. It's pretty difficult to retrofit them on top of the existing design, so I'm not sure it's possible. But basically, in my mind, companion objects as an abstraction for expressing methods associated with a class are a failure. It's not a very good design. We need to go back to just admitting that we have statics, basically.
The corporation never could understand what the difference is between writing a main object, curly brackets, all this JVM static, all this thing, instead of writing one single static word.
Yeah, that's a good point. So,
Is there something that I'm missing?
yeah, there is. Yeah.
Except from all this.
Yeah.
Okay.
Yeah. So it's when all you want to do is expose a static method, it's just noise in the code, right? So if all you want to do is this, you didn't gain anything by having companion objects. But the idea behind companion objects is that they are objects. They're actual instances of something. And this something can inherit. So here, do I have a mouse? Yeah. Here, you can specify superclass and super interfaces. And in theory, you can have constraints on generics with these interfaces. So it can be a rich, from the type system perspective, abstraction mechanism that can give you lots of flexibility. And many people use it in their libraries. Like they use inheritance for companion objects to reuse many things in their abstractions. That part is working. The problem is 80% of the use cases are very simple, and it's annoying to have it like this. So yeah, we made the wrong choice, prioritizing more complex, less popular use cases over the simpler, more popular ones. Yeah, so I had two big regrets about Kotlin design, companion objects and inheritance by delegation. So, another thing coming from CSharp, extensions. Extensions are a big deal. So, just to give credit properly, the person class declaration, this syntax comes from Scala directly, like this is proper Scala, I believe. And the extension function syntax doesn't come from anywhere. It's sort of a blend of the idea from C# and the syntax from C++. But the concept is very important. So basically, many people use extensions as a way of monkey patching a library, right? The string class doesn't have my favorite string manipulation method. I don't control it. I can't go to the JDK and just add the class, but I can have an extension function that will add my favorite whatever function, capitalize my way. And this is by far the most popular example, but the idea behind extension functions is much bigger. The idea is, if you have extensions in the language, you can keep your interfaces, your APIs, really minimal. So you don't have to add 6 utility methods into the string class. So your string class can be really, really small. And on top of that, you can build whatever extensions, and you can build libraries of them and import those libraries and have all the flexibility without burdening the interface with all those utility things. So it's a big thing, and it's a pretty successful feature. I'm pretty happy with it. So this is the basic syntax. It's a blend of C# and C++. the way other languages have it is interesting, I think. So Scala's way is the top one, implicit class, rich person. It's, I think they fixed it in later versions of Scala, but back in 2010 it was like this. And it's basically, it means that you create an instance every time you call an extension function. So this implicit thing means that at the call site, where you say full name, there you the compiler injects an instantiation of this rich person class constructor that wraps the person and then calls the full name. And that's scary. And also, Scala's implicit mechanisms are weird and huge and intractable. And I have a history of this, debugging one line of Scala for 40 minutes because I couldn't figure out the implicits. So yeah, we went out of our way to make things explicit in Kotlin as much as we could. But the idea is the same, and they fixed the implicit craziness in the future version of Scala, and they tamed them a little bit. So we didn't inherit any of the syntax, but the idea is the same. And C#, of course, popularized extensions by far the most among the mainstream languages. C#'s way of doing this is saying that it's a normal static function. So there is this util class everybody hates, and then there is a normal static function there with this prefix on the parameter. So which means that that is the extension receiver. So we just made the syntax a little nicer, and otherwise it's the same thing. Any questions about extensions?
I think in C# is static class. You want to do an extension?
You need a static class, but all classes are static in C#.
So what is the difference between a combining object and extension?
Oh, that's a huge difference. Let me see. You can say that a companion object is similar to any bag of static methods. In this sense, there is a similarity, but the big difference is that an object, any object, is an instance in memory, and a static class doesn't have an associated instance. So basically, an object I can pass as a parameter to someone, and this I can't. This is just the namespace. So you can statically import it, for example, without a problem. In Kotlin, we can import from objects, but it's a special thing, and you need to support it at runtime, and so on and so forth. In C#, this is straightforward. It's just a static function that it costs nothing to import. Yeah, but otherwise, yeah, there are similarities, but the underlying machinery is very different. More questions?
Is an instance and extension method has one instance?
So in Kotlin, actually, extension methods can have an instance backing them. Like there can be what we call member extensions. And this is a complicated corner of the design. It's very useful, but it's complicated. But yeah, C#'s version is much easier. It's only static methods in classes, that's it. Like their take on this is very much simpler. Yeah.
Would you say that companion objects are like meta classes in Python?
The question is whether companion objects are like meta classes in Python. Well, companion objects are a very sorry impression of meta classes in Python, I'd say. So, yeah, it would make sense to assign all the meta class meaning to a companion object. We didn't go along this path because it's complicated. Meta classes are very difficult to type. In statically typed language, meta class is a huge challenge. It's very difficult. So basically, the attachment is the same. It's like a single instance that attached to a class. But in every other respect, meta classes are a huge, powerful thing, and companion objects are nothing. More questions?
It's a little bit related about explicit versus implicit. there's a new feature of the context receivers,
Uh-huh.
and it feels like it's a little bit defeating the purpose.
Okay, yeah, good question. Thank you very much. So, all along, I was saying, like, for years and years, that Kotlin's making things explicit. But actually, we, throughout the history of Kotlin, had implicit things. Like there are those extensions that can bring this into the scope. I'll talk about them later. So here I'm just putting a pin to this and we'll talk about it. There is a contradiction and I'll tell you how I feel about it. Okay, so basically we're very close to that section of the talk, so I'll just refer to that one. It's Groovy time. Groovy has influenced Kotlin quite a bit. It's an unusual influence because at the time Groovy was completely dynamic. So in a static language, you can't learn very much from dynamic languages because those folks get to play with everything, right? So they can do anything they want and like change your classes on the fly and so on and so forth because there is no static typing that I have to obey to, right? So a big question would be, why is Kotlin a static language and not dynamic? What do you think? Yeah, the keyword is big projects. If you want your huge code base with a lot of people working on it for many years on end, you need reliable tooling. You need refactorings, you need inspections, you need everything. So you need basically machines to be able to understand your code. Dynamic languages is code that only people can understand. Static languages are code that machines can't understand. So that's why Kotlin is static. But we, of course, everybody in the static world envies the vast power of dynamic languages. And everybody in the dynamic world envies the tooling they have on the static side, right? So we wanted as much of the power, expressive power of Groovy as we could in Kotlin that our smart compiler could provide, right? So we were trying to have something like that. And this small bit is easy. It's not something very dynamic, actually. So first of all, we took the syntax. Syntax is easy. Syntax is static, even in Groovy. So we allowed this, a lambda, to be passed without around parentheses around them. That's great. That saves us keystrokes. It saves us noise. It makes functions look like they're blocks of some sort, sort of makes Kotlin more DSL-ish, so on and so forth. And we also took the idea of it. It's controversial because if you nest many lambdas one inside the other, those its go crazy, right? But there is a pretty simple discipline around Kotlin code where you don't get lost in your its, and it's pretty useful, so we kept it, and I think it served us well. So this example is basically sort of similar to comprehensions in other languages. Comprehensions are much more powerful in the compiler sense, but meaning-wise, it's good enough for comprehensions. And that's the easy part. And this is what we're choosing from. Other languages have the same meaning in different syntax. So the top one is Scala. And Scala is completely magical because the second you have an underscore, it's a lambda. So here, it's suddenly, this whole expression is a lambda, and this is implicitly the parameter of this lambda, and you're calling something on it. So after writing some Scala, I was like, we are never having anything like that. I want my lambdas to be visible in the code. Otherwise, it's like you're lost in a second. So in Kotlin, there is a very simple rule. Every lambda has curly braces around it. There is no way you're having a lambda that doesn't stand out in the code. So this is why we didn't have this, but we have something reasonable. In terms of keystrokes, it's almost the same. We have curly instead of round and it instead of an underscore. That's it. So the second thing you probably recognize is Java. Too verbose, we couldn't have that. And the bottom is C#. It's pretty close, actually, to what we have. The names are influenced by SQL, basically, through a link. And yeah, so this was good influence. We tried to use it. But a much more interesting thing about Groovy is actually Groovy builders. And builders allow you to do things like this, which is, in Groovy, it's a dynamic feature. So basically, a Lambda can import a receiver implicitly into the scope, and everything will be called in this receiver, which is cool, but you can't do anything like that at runtime in Kotlin. It's, first of all, very expensive, and also you can type check that easily. But we wanted to do something like this, right? So we wanted to be able to write functions like with that just save us a lot of repetition. Any questions about this example? Okay, is the code clear? But if anybody here ever wrote Pascal, this is native in Pascal. Yeah, it was actually the first language I wrote any substantial programming. I was writing Pascal for a couple of years during my high school and early student years. And by the way, speaking of giving credit, the person who probably taught me the most about programming languages implicitly is Anders Hausberg of the C# thing, but he did that through Object Pascal. I was using Delphi. Don't know if you've ever heard of that programming environment. And it had its a successor to Turbo Pascal and Borland Pascal. And the person behind that is Anders Hausberg, who later was invited to Microsoft and did C# and then TypeScript. So he's actually taught me more about programming languages than anybody else, because through his languages, through his language, one of them, I was learning programming. And it was actually a funny story, because at some point I was reading my first book on C#. I remember I was on a bus. I was reading a book, and it was before smartphones and everything. It was an actual physical book, like a huge one. I don't remember how I carried it on a bus. Never mind. So I was reading about the syntax, and there was this weird keyword in C#, like it said, like methods are virtual, but if in a subclass you want to hide a virtual method legitimately, like if you want a method with the same signature, but you don't want to override it, you can put a new keyword somewhere in the signature and it will work. And I'm like, wait a minute. This is weird, but Object Pascal has the same. Is this the same person? And yes, it is. And nobody uses that, by the way. Yeah, so coming back to Groovy and builders. So basically, we had an explicit goal. We liked this. Actually, my colleagues at JetBrains liked, they wrote Groovy for their tests quite a bit. They liked this dynamic closure scoping syntax for builders in Groovy, and we wanted this for Kotlin. But it's not easy to type, because you need to figure out like how do you express this in a static language. And you know that we came up with something that allows us to write this, where, of course, HTML and body are functions, and these are lambdas, and this is a function too, and this is just a named argument to a function. So this all plays out nicely in Kotlin, but I believe it was one of the things we invented. We didn't mean to advance the art, but we did a little with this. So basically, the idea was not to add this as a separate feature to the language, because it doesn't look good if we are just supporting this DSL pattern for the sake of it. So we figured out a way to combine different things here: the syntax for lambdas, function types, extension function types, and this all plays nicely together, and you can type DSLs like this. Through a combination of orthogonal language features you can use in other places as well. So I'm pretty proud of this. And here we can talk about the implicit receivers and everything. So basically, the way these DSLs work, every function here has a lambda whose type is an extension function. So this curly brace after HTML is an extension function on the class HTML, where it has HTML has the methods, body and head and whatever, just to reflect the structure of what's allowed inside an HTML tag. So this is implicit, right? So we are introducing a this, which is implicit inside those curly braces, and in the nested curly braces there is another this that's also implicit. And what about making things explicit in Kotlin? Well, that's a trade-off. Of course, every time you introduce any hard rule, it restricts you quite a bit. And we were always about being pragmatic. Pragmatic meaning we are not doing things if they are not practical. So we believed it, and I still believe it's a practical thing to have this much implicitness in Kotlin, because it's very beneficial and you can sort of contain it inside your DSLs and it won't pollute everything else. Now, there is a new design by the Kotlin team of context receivers, which sort of extends this implicitness a little bit. I've been on the phone with my colleagues in Kotlin after I read the proposal because I had some ideas I wanted to bounce off them. And we were talking a little bit about like this initial iteration. It will be improved quite a bit. So you shouldn't expect this particular design to be a final and released in Kotlin. It's now just for experimentation, for playing out with it. But it seems like we can keep the implicitness to a reasonable level, keep it useful, and enable many things without polluting everything else. That's as much as I can tell you. If you have any particular questions, I'm happy to discuss it after the talk. Okay, so fun thing. What language is this? Basic. It does look like basic, but it's not actually. Any other guesses? Fortran. Okay, it does look like Fortran as well. Basic looks like Fortran. Okay, what's the language? Scala, right? This is Scala. This is actually an example that Scala people showed off on their documentation page at some point. It's impressive how flexible Scala can be, but my personal opinion, it's nothing to be proud of. So when we designed DSL capabilities in Kotlin, we were pretty deliberate about not letting it go haywire. So we didn't allow any like weird characters like this and nothing like this and so on and so forth. So Kotlin DSL capabilities are very limited. You can't add new operators. All the weird characters are reserved by the team. Like if you want your own character, come work for JetBrains. Yeah, it's our hiring strategy, you know. Yeah, used to be. So yeah, we like the idea of DSLs in different languages. Like DSLs in Groovy are great, DSLs in Scala are great, but a little scary. So we wanted a sweet spot somewhere in that space. And basically what we went for was a little bit of syntactic flexibility. Like we have infix functions, we have overloading for operators, we have those type builders, and a few other things, but that's it. Like you can't have anything else. So this is the Kotlin stake on DSLs. Any questions about DSLs? Anybody wants to write basic in their Kotlin? Maybe.
So you say it was by accident?
No. It was pretty deliberate.
No, you say like we didn't plan for this and they just came up. What do you mean by that?
No. I think I might have misspoken. So it was pretty deliberate that we wanted to limit the ability of our DSLs.
I'm not talking about the limitation. I'm talking about how it came to be. Like you said, we as Kotlin, we didn't intend to advance the state of the art.
Oh yeah. So the anything new that we invented as designers of the language is accidental. So we didn't plan to invent anything, but we ended up inventing some things. just because we had to. But it was never a goal. Like we didn't mean to advance the state of the art, we just had. Okay, now another thing we completely learned from Scala is data classes. So it's basically the bunch of things generated for you automatically if you just apply a data keyword. Scala has this in the form of case classes. They generate equals hashcode and toString. We added component 1, component 2, those destructuring methods, and a copy. But basically, it's just one-to-one copy from Scala. So an interesting conversation, though, is how we dealt with the idea of pattern matching. So Kotlin has no pattern matching. Scala has a very powerful pattern matching, and actual reason for having case classes in Scala is pattern matching. So they are called case classes because you can switch case on those classes. And in Kotlin, we designed pattern matching in the very beginning. So I had the grammar and I even wrote a parser for it. But then I looked at it and it was like a lot of work from the compiler. So it was a huge part of the language that's basically focused on a very, very tiny fraction of the audience. Basically, there are two kinds of people who like pattern matching. Haskell people, who just like it for the sake of it, and compiler people, who are my people, and I have empathy for them, but I'm not adding a huge thing into the language just for the sake of them. So basically, we went with something like very, very weak in terms of pattern matching, just the structuring and smart casts, and that's it. But we simplified the language design a lot. We don't have so many problems because of that. So since the Java team is looking at adding proper pattern matching to Java, we may have to revise this later because it may become like the mainstream thing and everybody will expect it. Well, we saved ourselves 10 years of not having that, which is good. Yeah, so the structuring is the syntax when we just call component 1, component 2 to assign to the two variables there. It's not the best design ever because it has problems, and when you change the code, you can your types may flip. I mean, your names may flip without the types flipping, and your code will mean a different thing. People complain about it. The team is looking into maybe changing this, but it's not easy. Any questions about this? All right. So yeah, so this is what we don't have in Kotlin. Yeah, all the better matching stuff. What we have is close enough with when and match-like is clauses and smart casts. So smart casts are actually a big thing. I don't believe any mainstream language ever had smart casts before Kotlin. But there were smaller languages that did, and we learned from them. I don't remember which one it was. It may have been Gosu or Phantom, I don't remember. But yeah, so the point of this, it's actually very important that Kotlin doesn't want you to write explicit casts where they can be inferred by the compiler. Because casts are bad. So the basic idea behind this design is that in Kotlin, if you have to cast, you need to have a very good reason. So normally, the as operator should be prohibited in your code base. It's only for a very limited number of use cases that only like big wizards on your team should be actually dealing with. So all other cases, the compiler should be smart enough to figure out your casts for you. So you don't need to know about the as operator. And this is more or less working, I think. The algorithms are complicated, but it's worth it. So, of course, a huge number of casts come from nullability. Like we need to figure out a way of, on the one hand, keeping track of nullable and non-null types in the code, which basically doubles the number of types in the universe, right? It's actually more than that because it's exponential, but it's like vastly more types, and we have to make it ergonomic. So we had to add quite a bit of syntax to deal with that. This Elvis operator for defaults, save calls, and their combinations with Elvis, the double exclamation mark. Why do you think it's double? Say again? Yeah, to be ugly. Yeah, that's a good point. Yeah. It's actually double to stand out. So the point is, again, you're not supposed to be using this a lot. It's you should check. You shouldn't assert. If you really want to, it has to jump out at you. It has to be loud. And also, one exclamation mark is too precious. We didn't want to use it for this. So yeah, and as is deliberately ugly as well. It has to jump out. It has to be inconvenient in terms of adding parentheses around it. That's all deliberate. As should be a pain, because you don't need to use it. And the last bit is generics. It's actually a whole different talk, because generics are complicated type theory thing and all that. But I want to give credit to all the ideas that we integrated here. So on the one hand, Scala pioneered the variance idea. The idea that your subclasses with generics can play nicely with supertype interfaces. Scala's syntax for that is you have plus for extends and minus for super, which is interesting, but not very self-explanatory. So the syntax we borrowed from CSharp, who added this, I believe, after Scala. So this is a blend of Scala, Java, and CSharp, where we use Scala's declaration site variants and Java's use site variants. So in Scala, you write your ins and outs, your pluses and minuses here. In Java, my computer's not responding, sorry. Yeah, in Java, you write your ins and outs, your supers and extends here. Kotlin has both, which never happened before. So we needed a consult from academia. Ross Tate from Cornell University was helping us with this design. We mutilated his idea like terribly. It's, you know, when an academic person writes a nice mathematical structure and then engineers come and try to make it work in real life. It's ugly as hell on the inside, but it's working pretty nice for the user, so it's okay. Yeah, so we combine both declaration site and use site variants. We use the C# syntax of outs and ins, which look more self-explanatory to me, but C#'s design is limited. They only have ins and outs on interfaces, not classes, and only on the declaration side, not use site. So that's an interesting combination there. So yeah, I'm close to ending this talk. There are many other things that happened. Like we use unit instead of void, which is weird both ways. First of all, so we all owe the word void to Dennis Ritchie. I have no idea why Dennis used that. Void means nothing. And Kotlin has the word nothing for nothing, which makes more sense in English. Void in its actual semantics in C and all the languages after C is not nothing. It's nothing interesting. It's a different thing. We didn't come up with a good name, so we borrowed unit from Scala. Unit is very academic. Unit is actually a tuple of no elements. You know, but we didn't come up with a better name. So we couldn't say nothing interesting, it would be too long. So yeah, we're stuck with unit for lack of a better name. We have this weird syntax for annotations. Comes from C#, nobody uses it. I regret having edited it. Soft keywords I already mentioned. And there were languages, I don't remember which language inspired me with soft keyword, but C# used a little bit of them, I think, before Kotlin came about. Inline classes, the idea floated around quite a bit. So now Scala has them, and I think they invented them before us. So we sort of eavesdropped on their design and so on and so forth. And coroutines, of course, are not a new idea. Coroutines come a long way from the 60s or something. But Kotlin's implementation is quite interesting because most of it is in the library, which never happened before. So many things there. Any questions about these?
Coroutines are very similar to Akka in terms of usage. That's, you can use it for the full
Coroutines are similar to Akka. Something similar to Akka can be implemented using coroutines, but coroutines are a lower level concept that can be, like Akka is only message passing between actors, which is already a library abstraction for Kotlin. So you can do Akka-like things in Kotlin through coroutines. Coroutines are more basic. And frankly, you don't need Akka for many things. You can just do coroutines. More questions?
Are there things which you have regretted that you were able to revert?
Oh yeah, we dropped so many things.
How does that go?
Well, we, as I mentioned, we dropped multiple inheritance for classes. It was a miserable failure. We dropped pattern matching, halfway implemented, just dropped it. We dropped tuples from the language, for example. There was a special syntax for tuples, so on and so forth, but they duplicate classes, the simple declaration for a data class, so we dropped tuples. And there were, I think I'm not remembering many things at the moment. There was a thing I'm very much on the fence about, but I actually should have done a ternary operator, an inline if, because everybody wants it. And the normal if is kind of lengthy. It is redundant, but I should have edited it. And it's very, very hard and almost impossible to edit back. So probably there's no going back on this one. Yeah, it's a long story. It's really painful.
Spoke about generics, and that reminded me that Go and just got generics as a thing. But I noticed Go and Rust weren't part of your languages you're inspired. Are they too young as languages?
Yeah, they're too young. So Go only conversion their generic design after Kotlin 1.0. So we didn't have a chance to look at them. And Go's take on generics before that was like very strict. You have generic classes, 3 of them. Function, map, and list. That's it. So we couldn't go that way. Rust type system is so complicated, you can't really learn anything from it unless you're Rust. It's beautiful, but it's very complicated. More questions?
Do you think about using something else instead of generics, like using the templates from C++?
So generics versus templates. Templates from C++, as they are in C++, are terrible, crazy thing. Because it's code generation on the fly. It's slow as hell and all that. So there is this idea of concepts, I think they are called, trying to type the templates. And it's sort of similar to Haskell type classes. A pretty powerful thing, but very difficult to explain to normal people. So we went, so first of all, we couldn't leave out generics because of Java interop. We had to have generics in some way. We had an option of like having generics and something much, much stronger like type classes on the side with the power of code generation underneath. We considered that many times in different contexts. It's very complicated. The code generation is not easy to handle. So C++ world has a sort of a privilege for the C++ compiler implementers. The C++ compiler is inherently slow. Nobody cares about like how many hours your code compiles. Like in our world, you do any sort of import search for too long, everybody's pissed at you. So we basically, we considered it, we didn't like the implications, we didn't implement it. but it may be that somebody figures out a way at some point of doing some tame code generation underneath that will bring more power than generics. There are proposals of something like type classes, many of them. Some, I think, involve some code generation. So we'll see over the years, maybe something plays out well. More questions?
What about lazy and latent? Where did you?
Oh, lazy and latent. Okay. So lazy is not a language feature. Lazy is just a use case implemented through delegation properties, delegated properties. Delegated properties are a very natural idea. There is an analog in Python. We didn't really look into their design because it's very natural, but we knew that they had something like that. So delegated properties were basically designed from use cases. We collected all the use cases we could think of and did the language part that incorporated that. That was it. Latent is a very ugly hack to support initialization. Basically, initialization of classes is the biggest pain of a language designer. If you have an object-oriented language with mutability, constructors and initialization are your biggest pain. And latent is sort of, it's a trade-off. It's an ugly thing we added to simplify our life quite a bit. So it's like, it's a bad thing, but inevitable in our design complexity. So to get rid of that, you need to add a huge part of language design, like an enormous thing that will check your initialization logic for completeness. And that's huge. So we decided not to complicate the language this much and add an ugly thing just to get rid of it. More questions?
I have a non-technical question.
All right.
How long did it take from kind of concept to production to actually getting Kotlin, to actually creating Kotlin? And then also, I guess, how long did it take to migrate JetBrains, applications and products? Okay, it's two questions. Let's start with the first one. So the first question is, how long did it take from the concept to production with Kotlin? So technically, it took from 2010. The language design was started in 2010, and until 2016 to get the first official release of the compiler out. That's very long. We actually found some dead ends on this street, network of streets that we traversed. It was difficult. It was also many problems with the implementation itself. So we could have done it faster if I were a more experienced manager, basically. But yeah, it took some 6 years, or actually 5.5. But in terms of adopting it inside JetBrains, we of course did it much earlier. I think in 2014, there were already substantial code bases written in Kotlin inside JetBrains, including the Kotlin compiler itself. It still has quite a bit of Java, but it had quite a bit of Kotlin at the time. So yeah, it was a very long endeavor. And JetBrains never migrated everything to Kotlin. We had a huge Java legacy code base, like, I don't remember, and tens of millions lines of code, I think. So it's mostly still in Java. But there is quite a bit of Kotlin there now, and all the new projects are started in Kotlin. So I don't think we have as much Kotlin as Java already, but we probably have as many people writing Kotlin, only Kotlin, as people writing some Java and some Kotlin. And JetBrains, yeah. I have another follow-up question.
Yeah, sure.
Come up. And with the time spent on building this language and all of that investment, did it have the ROI you were hoping for at JetBrains in terms of performance or simplicity or all the things that you're
Yeah, the question is the return on investment in terms of time good for Kotlin? The good thing about this is that you can't measure it, so you never know. Actually, I think it's very different for different points of view. So I think for the company has spent a few dozen $1 million, I think, on Kotlin's development. Maybe by now already $100 million. I'm not sure. And for the company, it pays off, I'm sure, because It's used in our own production. It's used for marketing, for branding, for like everybody knows JetBrains because of Kotlin. Like, you know, so many more people know JetBrains because of Kotlin than it was before. So it's paying off. For people who invested in Kotlin, I think the outcomes are different depending on the subjective perspective of each person. So I personally learned an enormous amount from working on Kotlin. I learned a lot of language design, of systems design, of management. I learned management the hard way, never do it like me, but yeah, I did learn some. You know, it's been 10 years. I've developed quite a bit throughout those years. I think many people on the Kotlin team also, we also had quite a few people starting their first job on the Kotlin team. So people right out of the university, we were hiring fresh graduates from universities in Russia. And this is a very good way of getting really bright people on your team and have them never leave because they don't know if anything better exists out there. But actually, they also like it quite a bit, of course. So yeah, it's my sort of personal bias. I used to teach before I started Kotlin, and I like to work with students. So we had a lot of interns, and the best of them we kept on the team. So it's maybe like half of the Kotlin team, maybe more, are people who started their first job at JetBrains, and they're really good people. Okay, so the observation is Kotlin seems to be more popular than Kotlin coroutines, and the question is, why is that, in my opinion? So first of all, coroutines came to be a lot later than Kotlin itself, so Kotlin had a lot more runway than coroutines. That's one thing. Another thing is that coroutines are applicable in a limited number of use cases, albeit very important use cases, but they're limited. So coroutines they shouldn't be as popular as Kotlin, of course. And another thing is that there are alternatives to coroutines, like there is RX Java, for example, or RX Kotlin, that were popular before coroutines came about, so it's quite natural that they're still used quite a bit. So I think coroutines are a very important part of Kotlin, and they will get more and more popular, but it will take time. And from both the development team, because we need to develop the libraries, and we need to advocate, we need to teach people how to use coroutines, how to benefit from coroutines, so on and so forth. And also the world will have more and more of those asynchronous use cases. So currently, I think like vast majority of coroutines uses are UI on Android, which is one very important, but not the biggest actual use case. And coroutines should be used much more for server-side development, for asynchronous programming. And that is the future, because most programmers in the world today don't know how to do asynchronous programming at all, not only with coroutines, with anything. And they will learn over time. So the question is, what was the initial motivation for making Kotlin? Again, different people had different motivations. For the company, I wasn't there because it was before I joined, but what they told me is that JetBrains was making tools for programmers since 2001, so for almost 10 years by that time. And they sort of solved the ID use case, and they were thinking like, what else can we do for programmers? And Dmitry Zhemerov came up with this idea that, okay, a good thing to do for programmers is a programming language. And it made a lot of sense because at that time, Java was stagnating. There was the Oracle acquisition thing, and Java wasn't really developing for years. And CSharp was way ahead, and everybody understood that they are stuck with an old language that's not evolving, and so on and so forth. So this offering was a very good one. That's on the one hand. Then for the company, again, it was like before Kotlin, JetBrains was a trend follower. So there is a new language, a new framework. JetBrains is making tools to use those things. So something gets popular, JetBrains follows. And Kotlin was a way to become a trendsetter. So we put out a language, people use it, and our tooling is default for that. And like we are making the market, basically. This, of course, made a lot of sense for JetBrains. And also, and I think it might have been the biggest motivation, actually. People at JetBrains were sick of writing so much Java, because again, Java was stagnating, all that. So they wanted a better language for themselves. And they tried other languages. They tried Groovy, they tried Scala. They didn't work for their use cases for different reasons. And they felt that there was the spot for a new language. So for the company was that. For me, like I was 26 at the time, and I was doing PhD work and whatever. And they basically came to me and said, like, do you want to create your own programming language in a company that's one of the very few that can actually put it on the market? And I'm like, sounds a little crazy, but if I pass on this, what else should I pass on in life? Like, it would be completely crazy to do that. So I took the opportunity. I understood that it might not work out at all. And my sort of soothing idea was that, okay, if it doesn't work out, I'll learn a lot. So it turned out to be both. I learned a lot and it worked out. So yeah, for different people, I guess other people who joined the project, they had their own motivations. If I ever write a book about this, I'll ask them. More questions? Okay, so the question is, how much freedom did our team have in terms of designing the language as opposed to developers from JetBrains coming and asking for specific features? So we had all the freedom, so we didn't have to answer to anybody's requests. Like we didn't have to. We wanted to, because many people had sensible requests. But of course, like the very first year maybe of Kotlin design was lots of people coming to me and sharing their great ideas about language design. And I was like, oh man, how I politely tell this person that it's all great, but it's never making it into the language. And yeah, so this part of any designer's work of saying no a lot, I learned very early on. But yeah, nobody was forcing us in any way. But there was a lot of useful input from different people. Oh yeah. So the question is there any support for multiple inheritance on the JVM? No, there isn't. So the crazy plan, it was completely wrong, was to emulate multiple inheritance with delegation, and it doesn't work at all. Like, don't even try it.
Can you deliberate how Kotlin multi-platform, like from your perspective, from language design perspective? Kotlin multi-platform versus Kotlin for JVM?
Okay, yeah, I'll tell the story. So yeah, Kotlin was initially conceived as a JVM language. So the very first takes on the design were JVM only. But then, of course, we were talking about maybe getting Kotlin out to other platforms because for one thing, at JetBrains, people were writing for .NET and for other platforms too. So there was an idea of having multi-platform Kotlin in some way. Nobody knew what it meant. But there was this idea that we can have Kotlin not only for the JVM, but for other virtual machines, at least virtual machines. And actually, people still come up to us sometimes and ask, like, why don't you make Kotlin for .NET? And the honest answer is it's so hard, it's not worth it. So basically, the actual design on the Java virtual machine is quite a bit JVM specific. So you can't easily make the same level of interoperability work on a .NET. So CLR is very different from the JVM. But you can do something pretty good on the JavaScript virtual machine or on a WebAssembly virtual machine
because those virtual machines are more permissive. So there was an idea of multi-platform. There was an understanding that we need to decouple the design of the language from the virtual machine restrictions, and we tried to do something along these lines by introducing Kotlin JS very early. So Kotlin JS started as an intern project and was sort of a side project for the team for a long time. And the idea there was that we have to look at an alternative runtime to decouple the language from the runtime. It had a limited effect, so we decoupled some things, we didn't decouple other things, and so there we are. Then Kotlin native was added, and that's a whole different story of having our own runtime, and we did a crazy experiment of completely changing the philosophy of memory management there. That fell apart like miserably, and we had to rewrite everything. And now the new garbage collector is doing the same thing it's doing on the JVM and JS and whatever. So yeah, so Kotlin multi-platform was initially a very abstract idea. Then it was implemented with JS, and then native was added. And then we started to realize what multi-platform actually means, like from the language standpoint. What does it mean? And this is where expect and actual come from. And this actually it's pretty complicated module system, the static module system that we have to facilitate compilation of common code mixed with platform-specific code and all that. So basically, from the design standpoint, that is multi-platform, and it's very complicated, and it's not finished yet, and I think it will take a few years more to flesh it out completely. More questions? Yeah, the question is since I left JetBrains, what are my plans, or what am I doing? So I left JetBrains in December 2020, which is a year and a half ago. And by that time, I was already working on a different project in parallel. Never do that. It's not good for you. I started another company in parallel with Kotlin in 2017. Fortunately, I had a co-founder. So that company does something completely different. It's not, it has some programming inside, but the product is psychotherapy. So we provide psychotherapy services to people who speak Russian all over the world. And that's a completely different part of my life. I wanted to do something not only for engineers, but for everybody. And I was doing that in parallel with Kotlin for 3 years. I almost died. Don't do that. In any case, I quit JetBrains in 2020. Basically, one of the main reasons was that I sort of felt like I've solved every kind of problem there was, and all the new problems I'm working on are sort of instances of something I've seen before. So there is nothing completely new. I know how to do this. I can do this like with my eyes closed and half asleep, and I do it well, but now it's not interesting anymore. And I don't regret that. So since then, I was working on that other company, and now I'm thinking about starting another one in a completely different field. So yeah, that's it. Yeah, the question is whether we wanted any higher conceptual level features in the language, something for cloud computing or something like CSharp's Link, so on and so forth. So something like Link was on the roadmap since day one. We understood that it would be cool to have something like that. We never got around to it. So maybe one day it lands the language, I'm not sure. We were looking specifically into cloud use cases. And from the language standpoint, there isn't very much. But there are interesting ideas because when you try to define your cloud infrastructure as code, there are interesting things because there is this configuration time, and then there is runtime, and it's all the same code, and you need to somehow separate the two, but you want to refer from one to the other. It's very interesting. You can design an interesting type system around this. There are sketches on the blackboard about this, but I'm not sure it's on anybody's roadmap. I just don't know. But it was there on our
very strategic roadmaps 2 years ago. So yeah, there are very interesting fantasies about what you can do, but you can actually implement only so much with the resources we have. Yeah, yeah. Yeah, so the question, I can rephrase your question as like, Gradle, really? You know, it's a sad story. So Kotlin historically was build system agnostic. We didn't prefer any build systems. And we integrated with IntelliJ's own internal build system that's used inside the IDE. Behind the scenes, we always had Maven support and Gradle support. And when we got big on Android, Gradle became a big priority, and we started investing into it. And then multi-platform came about, and it requires a lot of flexibility. You can't do good multi-platform on Maven, no way. So we needed something to do multi-platform on, and we did it on Gradle. And Gradle is not perfect. Gradle is not perfect, but it's the best thing there is for the task. And everybody understands that Gradle has its shortcomings, and people are constantly looking into maybe making something completely new and nice. And there are projects at Google, at Facebook, their own build systems. They have their own design decisions shaping things around them. So I think there is at least one project of build system direction inside JetBrains behind the scenes now. I'm not sure what the roadmap of that project is, but there are basic things that everybody wants. So one thing is zero configuration time. So the problem with Gradle, and to a little extent with Maven, but mostly with Gradle, is that you have to execute code to understand what's in your project. That's very bad, because executing code takes time. And this means that when you check out your source from version control, you have to execute code right away. And it takes time, and it kills your productivity. So it has to be somehow decoupled. The configuration of the project should be static, and all the executable stuff should be something else. That's one thing. And also static means static. Like, you don't need to do any dynamic things in the configuration. So these are very straightforward ideas, not very easy to implement in a way that can cover everything that Gradle covers. Because Gradle may be not perfect, but it covers every use case there is in the world for everybody. And it's not easy to cover. Okay, Micronaut. Okay. So the question is about server-side frameworks, and there are many of them, and Spring is the big flagship, but there are others like Micronaut and whatnot. So I'm not sure if anybody is targeting any third-party frameworks other than Spring, because there are many of them. I think the general idea today should be that we sort of don't block them. But Kotlin has Ktor, which is Kotlin's native solution for server-side, and has Spring, which is the biggest client. So these two, I suppose, should be priorities. And the rest is like, we tried not to block them, but we can't really invest into supporting them a lot. So that would be a reasonable approach with the resources given. And the Spring moves pretty fast in terms of modernizing things inside it. So it may catch up with Micronaut and others in the next few years.
Generics seems to the first reader, even the second time you read the documentation, complicated.
Yeah.
And sometimes it takes, you read it again and again and again, it still can't get it. So what was your take on it?
Okay, good observation. Generics are complicated. When you, even from the first read of the documentation, you can see it's complicated. The truth is they are, and it's inherent complexity. Problem of generics, so I'd like to give you a little background. So when we talk about a object-oriented language, generics are not part of that. Like, a purely object-oriented language doesn't have generics. Generics are actually a functional feature. Generics come from the functional languages because they help you generalize code in a different way. So object orientation is about one kind of polymorphism when you have dynamic overrides, right? So you have your virtual method table and it gives you overrides, and that's the kind of polymorphism that you get in OOP. Then in the functional world, you have different kinds of polymorphism. You have parametric polymorphism, where you say, this code works modulo this type. I don't know what this type is, but this code will work on anything that's shaped like this. And this is generics. We say that there is a parameter that we statically know. We know everything we require from this parameter, and you can substitute anything at runtime. So this is a foreign concept for an object-oriented language. And it was integrated into object-oriented languages before us by the Java team, but mostly by Martin Edersky, actually, who designed Pizza for Java generics. And then I think C# was inspired quite a bit by this design as well as Java, but I'm not sure. In any case, it was solved more or less by other people before us. We inherited this. I don't think they could have done their job much better. So there are small things about generics in Java in particular, or in C# in particular, that I would like to change, and I did change them. So use site variance is much better than, declaration site variance is much better than use site variance. Everybody learned that. We have declaration site variance and use site variance basically for backwards compatibility with Java. That's one thing. The kinds of constraints you have are, they define your flexibility quite a bit. And Kotlin has different types of constraints than Java. And the kind of type inference algorithm also defines a lot of things in your language, so on and so forth. But basically, the idea of how you slap generics on top of an object-oriented language, it's the only way you do it. There is one way. There is an alternative, theoretically. The way it's done in Go. Go could live without generics for a long time because they have a completely different type of polymorphism, because they have structural typing. You don't have to have a subclass to conform to some protocol. And Swift has it in a nice way with protocols where you also can dynamically fit into something. So that can be integrated into the generic picture and make it even nicer in a way, but on the JVM it's just too complicated. You can't implement it well. So basically, yes. So the answer to your question, yes, it's complicated. Most people can live without knowing about all the complications because all they do is use the standard containers and they're fine. People who want to design their own generics need to learn about them. That's the cost of flexibility. You have a good abstraction. It's more difficult than other abstractions. You need to master it before you use it. That's it. More questions? Okay, yeah. So the question is, okay, you mentioned your hardships as a manager. What were they? Okay, so one thing is I started Kotlin with no management experience. And I had a very wrong notion that my experience as a teacher would count towards my management experience balance. It doesn't, no. So basically the biggest mistake I made, I didn't have a mentor as a manager. I started doing something I had no idea about without anybody to mentor me. Don't do this. It's gonna end in a lot of difficulties. So a few particular things that were hard was like for every manager who grew from a specialist, learning to delegate. The problem is, and I mean this as in a bad way, so I'm not being too immodest, I'm smart enough to micromanage 32 people. I'll die, but I can. And so it made me, basically, I could get way past the point of manageability. Like when you have 10 people, you just start delegating. You can't micromanage everybody. But I got to 32 or 35, I don't remember. And I was like, I kept track of every single person on the team. And that was crazy. Of course, I couldn't do any work of my own, like anything. But it was too late. Like at that point, I couldn't just start delegating. I had to drop a few things to start building up my management routine somehow. That was one thing. Also, I didn't realize how important it was to build a team from the beginning. So I was kind of shy of inviting other people who worked at JetBrains to join the project because I thought it was sort of an experimental, very risky, and I didn't have the right to sort of distract engineers from more important projects. That's wrong, don't do it. If you believe in your project, like get the best people you can as early as you can. And so, yeah, that was a big mistake. Also, we should have put 1.0 out a lot earlier at the expense of the quality of the design. So the way Swift did it in terms of release management is much better. They put out 1.0, they broke compatibility for years, but they had something out and people could adopt it already. It was, their approach was much better. And we had feature releases for a long time, and it's wrong. Once huge projects don't do feature releases, do date-driven releases, just release regularly. It's much healthier for everybody. Otherwise, you're just going crazy yourself, your users suffer, like it's bad for everybody. So yeah, it's just to name a few. So in every aspect of management, I made many, many mistakes, and I learned from them the hardest way there is.
What was that like?
Okay, so the question is, what's my take on compatibility? Compatibility is the biggest design constraint for Kotlin. It has always been from the very beginning. Kotlin is all about compatibility. It's the strongest side of Kotlin. And we went into great lengths to have compatibility. Like we spent, I think, in terms of design and implementation effort, we spent more time on compatibility than on anything else. So our Java interop, our backwards compatibility between versions, it's huge, like all of that. So I think this is one of the strongest points, and it's one of the reasons why Kotlin worked for so many people. And fortunately, we dropped Java 6 recently, and I'm so happy because Java 6 was dragging us back the whole time. It was completely data-driven, so we just knew that too few people use Java 6 anymore, so we can drop it. We dropped it. That was it. So it was never compatibility for the sake of the symbol. It's for practicality. So we didn't want to hinder people's work. We knew it was very few people, and it's fine. Yeah, we dropped it. I'm so happy. The biggest problem, by the way, was not the virtual machine. So Java 6 is more or less the same as Java 9 or whatever in terms of the language, but the library depends on the JDK, and that's a huge pain. So yeah, it's so much better without Java 6.
I have a question about the compiler plugins.
Compiler plugins? Oh, what do you want to know about?
What would be the scope of what we can do? Could we add a soft keyword?
Okay, all right. Okay, the question is, how powerful will compiler plugins be? Can I add my own soft keyword, for example? Can I add a hard keyword? Like, how much fun can I have with your language through a plugin? I can't speak for the designers of the plugin API, but from common sense, no hard keywords. No way in hell you're having hard keywords. Probably not, no soft keywords either. So actually, the compiler plugin API is a very difficult thing that we are figuring from the use cases. So Kotlin has an extensive set of plugins already, and the biggest plugin for the Kotlin compiler is Jetpack Compose, and that is huge. And basically, there is no API. There is an agreement between the two teams. Like it actually worked like this. So the history of Jetpack Compose is quite spectacular. So they came to us with an actual plugin for the syntax. Like they altered the syntax, and we pushed back like very hard. So guys, no. We can give you like all the flexibility in the rest of it, but don't touch the syntax. And finally we came to an agreement on that. So we gave them a lot of flexibility in terms of where they can plug into the front end. Like they can do types, they can add things, like they can interpret different scopes differently, whatever. There was like a lot of flexibility. Basically, you plug into the very heart of the front end and do anything you want there. But it's already past the syntax analysis. And then with the backend, they just had a fork of the compiler and did whatever they wanted and submitted patches to us, and we reviewed them and came to some sensible API there. So for a long time, Compose lived on top of their own fork because they wanted to move fast with the backend. And backend has lots and lots of work on it in terms of API. So that was a very ad hoc solution for a very complex problem. And I think we did pretty well. So folks over at Google did a great job in terms of shaping Compose itself. Compose is a beautiful design. And it was, in the end, it wasn't too painful. So the API surface that emerged from that is not too bad. It's not perfect, but it's not too bad at all. And how much of that will be turned into like actual public API for everybody to use, it's an open question, because it's not only the compiler, it's also the build system and, most importantly, the IDE. Because the IDE has to figure all this crap out, which is not easy at all. But I think it's tractable. We have a very good use case there. We have a number of other plugins. Historically, we were supporting many things through plugins. So there is a lot of input to work on for the API. There are good people on the team who know about APIs. So I think it's tractable, although very complicated. I don't think they will stabilize the API in the near future, but there will be some iterations on it. Hopefully they will get around to it for, I don't know, maybe 1.7, 1.8. I'm not sure about their plans. Say it again?
Hopefully we'll have some documentation.
Oh, yeah, and that's a separate story, by the way. So it's one thing to design an API, and another thing to document it properly. So yeah, it will be a different story. And if there are any volunteers, help Kotlin with documentation. There's always a shortage of people who can write good docs. It's interesting how it's much easier to find a genius engineer than a genius doc writer. Okay, we have to wrap up. So last question. Okay, the question is there a difference in terms of performance on different implementations of Java? Like there is Java 8, there's Growl, there is Java 11, Java 17. I'm not informed enough to give you a good answer, really. There are differences. So we are adding support for new bytecodes. Some of that will affect performance in some way. I don't think there is any dramatic performance improvement anywhere, but some things are nicer. Like, I'm not sure if it's implemented already or on the roadmap, but there is this stuff about using proper Java 8 lambdas instead of our own lambdas. That would be a little faster in terms of loading classes from disk, for example, or like your jars will be smaller and so on and so forth. But it's not huge. I'm not aware of any huge improvement that will have, maybe with something very specific, like some specific application of coroutines somewhere, maybe some newer JVM is better, I'm not sure. Okay, we have to wrap it up. Thank you very much. Lots of interesting questions.